spots. So for those of you who weren't here earlier, if you somehow don't know Steve Carpenedo, Steve is the DEQ Wetland Program Center person. He's a professional wetland scientist and a senior wetland scientist here at DEQ. So I'm not going to take up your time by introducing you.
All right, no, that's okay. Thank you. I do want to say right up front I'm using a new presentation format, and I hope it works. So if you see me struggling a little bit, I apologize. So today what I'm going to actually talk about is some wetland assessment work that we conducted in both the Musselshell and the Red Rock River basins. And this talk is very much a methods talk more than, it centers on disturbance and condition, but it's more methods of what we collected initially and how to better answer our questions, what we did to modify our methods. And if anyone hasn't seen this, this is a story journal format, so there may be some funky things going on. So we started monitoring the Musselshell in 2014 as part of a larger investigation into water quality and habitat conditions across the basin. Our goal from wetlands was to understand the effect current and past land use practices have on the functions wetlands provide our communities, the environment, and the economy. We wanted to use this understanding of the effect to help implement and suggest appropriate best management practices to protect, restore, and maintain wetlands. So we used the Ecological Integrity Assessment Protocol developed by the Montana Natural Heritage Program. And the one that we used, which I know has been updated numerous times, was 2015. We used 2015 because we were collecting data 2014, 15, and 16. So we stuck with that 2015 data. At every single site we visited, which was 163 sites across the Musselshell, we conducted a level 2 rapid assessment, which we went and we collected vegetation data, dominant vegetation data within each plant zone, soils data, disturbance data, as well as other indicators of ecological integrity. At 25% of the sites, we also went and did the intensive assessment. For purposes of this talk, the intensive assessment, I'm going to focus more on the vegetation aspect of that, the wetland vegetation aspect. So this is where I'm actually going to get into methods a little bit more, especially the collection of disturbance data. So to collect disturbance data in the Musselshell, we went and we looked at what disturbances are present in both a 200-meter buffer, which is the green, and the assessment area, which you'll hear me say AA quite a bit. What is the percent of the analysis area and the buffer where a disturbance is observed, and what is the potential impact on the ecological integrity of that disturbance? So is it likely to modify, degrade, or destroy the functions and condition of this analysis area? The 2015 protocol didn't give a lot of guidance on how to best collect disturbance data in the buffer. Not so much the AA, but in the buffer. And so it was really left up for us to decide, okay, how are we going to, in a rapid assessment, collect good buffer data within 200 meters of this analysis area? And what we decided on is that as we walked into a site and were evaluating whether the site was able to be assessed, we would walk, basically a cursory walk around the buffer as we went to the center point. And then as we were setting up our analysis area, we were also looking, okay, what stressors are present, stressors or disturbances are present, and we were making a note of those on the checklist. Okay, this disturbance is present, this one is present, this one is present. We then went back after, pretty much at the very end of the assessment, and we said, all right, these are present based on our printed site maps. what do we think is the relative percent that this disturbance is present in the buffer, and what is that impact? We did the same for the analysis area. What is the percent of the disturbance that is present in the AA, and what is its impact? We then, after all this data was collected in the field, we were going to use this to help us set up disturbance gradients for the Musselshell River Basin from least to most disturbed sites. This disturbance gradient, and in particular the least disturbed sites, are what we classify our condition of wetlands based off of. This is, I believe it's exactly how you guys did it, or very similar. It almost exactly mimics the process that the National Wetland Condition Assessment takes. Develop a disturbance gradient and disturbance categories, and use that least disturbance category to develop condition categories for wetlands within the Musselshell. Okay. So when we went, actually after collecting the data, and I looked at it after our first field season in 2015, sort of a cursory look. Just, okay, what are we collecting? How does it look? Started noticing that we were going to have some issues in what we wanted to use this data for. But because we had 2 field seasons and I needed to use all of the data, I wasn't about to change methods in between 2 field seasons in the same site for the same study. So I was kind of stuck doing this for 2 years over the same process for over 2 years. And what we really started to notice is that we were going to have a lot of difficulty setting those thresholds for disturbance gradients in the Musselshell River Basin. And this is partly because of the process that we set up. We were not getting a lot of specificity to distinguish between not so much the presence of the disturbances, but the impact that that disturbance may have on the ecological integrity of the site. We also noticed that in the Musselshell River Basin, there are very few disturbances present. Grazing, hydrologic modifications, and those disturbances are present at moderate levels at almost every single site we sampled. Based on looking at area, for example, when I went back and I looked at the data, we had 11% of the area we surveyed did not have grazing in it. So very, very small area where no grazing was present. Not sites, but area. So what we did end up finally doing is that we were able to set disturbance gradients, but our tolerances are really fine. You'll notice that in the buffer, down here in the gray, we essentially could not use any disturbances in the buffer besides hydrologic modifications to help us develop that disturbance gradient. What instead we use is call it the scope and the impact of grazing, the number of agricultural stressors, and this numeric rating, the max numeric rating of ag stressors in the analysis area. And same with disturbance. Very fine tolerances, if you'll see. So besides the disturbance, observed disturbances and setting the disturbance gradient, we also wanted to look at plants and Fqa metrics. So as part of the intensive assessment at 25% of our sites, we conducted these intensive veg plots where we went out and we sampled 4 10 by 10 meter plots and recorded every species present, its cover, its height, its stratum. And I feel like there's other information that we collected in there. But we went out and did this very intensive assessment. To complete the intensive veg plots, took upwards of 6 hours for each site to complete. And that's an important number because that really informs when I talk about methods. So when we were doing this, I was trying to think about, okay, how can we use this intensive vegetation assessment data to help us understand what is going on at the site? And one of the ways that this is often used is with forested quality assessment metrics. These metrics look at plant communities or individual plants' site fidelity and tolerance to disturbance. One of the using the metrics, one of the things I wanted to test, or not one of the things, but many of the things, was the strength and significance of these FQA values and how well they correlated or described the disturbance categories, our condition scores, whether, because we were having so much trouble setting a disturbance gradient, could we use an FQA value to help us set as another threshold in the disturbance gradient? Or could an FQA value potentially even be standalone as a disturbance gradient measure? And in the Musselshell, the unfortunate fact is that it didn't help us with any of these. Okay? What we see is that across the whole basin, we have a pretty narrow range of coefficient of conservatism values, and it didn't help us separate out disturbance categories. It didn't correlate well with how we calculated condition, and we calculated condition 4 different ways. Besides NACA, besides heritages, I went 2 different ways because we're having so much trouble differentiating all this data. Essentially, the FQA data didn't help us at all. Not that it's not useful, it just didn't help us at all. And one thing I want, before I go on with this slide, people to think about and remember is that for both the buffer information and the vegetation information, it really came down to the conclusion that this is not what we're collecting. The data that we're actually collecting is good, but the process that we were doing it limited us on its usability. So one of the first things I looked at when I said, hey, why are we having so much problems with setting disturbance gradients in our condition and what this is telling us? And so initially I said, wow, did we really sample enough sites across the Musselshell River Basin, which is 6 million acres and larger than 5 or 6 U.S. states? Did we sample enough sites across the basin? And what we found is that spatially, we did a really good job spatially. We did a really good job sampling by land ownership, by land type, and different management. And so I'm pretty confident that the study design that we set up to do this was good, and it's not a problem of our sample and the number of plots that we did. And so it points to the question then of, or the conclusion that it's not what data we were collecting at these sites, but how that data were collected. The FQA metrics, while it wasn't usable to describe disturbance or correlate with condition, it did really help me understand, okay, what is going on in the Musselshell and why are we potentially having these problems? If anyone's been out in any place really in eastern Montana, I will say it's really a naturally high stress environment. In the Musselshell, salinity is very common. The hydro period of wetlands fluctuate greatly year to year. And a lot of these systems have developed with periodic disturbance, whether it's hydrologic disturbances or large herbivory. And so these are naturally systems tolerant to disturbance. And this is reflected in the conservation of conservatism values and the FQA metrics that we calculated. We see that for native species, our FQA values 75% of the sites that we looked at, the intensive sites, 75% of those sites have values between 3 and 5, which says that this is a stable native community that is tolerant of moderate disturbance, or it persists in moderate disturbance. When we add non-native species into this, we only actually drop it down to about a 2, but our top never goes up. And this picture here is one of the top sites that we sampled. Really nice native site. It was one of our highest quality sites as well, but the Fqa metrics are putting it in that category of tolerant, and persistent moderate disturbance. So this really helped answer that question. Why, when we're trying to set disturbances, everything is moderate, and how can we not separate this data out? That was our problem. We cannot separate out our data. The one issue that really came up with, for me, to make this Fqa data usable to help inform or use it as a metric is that, honestly, we only calculated it for 36 sites out of 163, I think, was our final. And so my feeling is that our sample size is really too small to be able to use this information for anything, but to help me understand why we're having issues. So based on that, my feeling was not the data we were collecting was wrong. The data is good, but how we were collecting it really increased or decreased our accuracy, and it really increased in variability between observers. I really like how Alden actually put up the number to show, hey, we win. We had different observers looking at individual plots, and this is the variability in their data. We did, and we looked at that, and what we really saw is that in our methods and how we were collecting that data, we have a big spread of variability, which affected how well we're able to analyze it. So when we moved to the Red Rocks in 2017, I sat down with Jen. Thank you. Jen Schutz with the Heritage Program. I also pulled in Sam Isham, who had worked for me as a tech for 2 years at that point, and really said, okay, how can we change our methods to both increase the accuracy of the data, the precision of it, and reduce the variability between observers. I also wanted to, I really liked Fqa values. I really wanted to see how can we collect this data at every single site we visit. And being that these are rapid assessments, how do we keep this at under 3 hours? And that was a big thing. Can we keep it under 3 hours was the question. So the first thing we did was to tackle the buffer, the disturbance information collected in the buffer. You'll notice from the previous slides that when I set a disturbance gradient, we didn't have anything but hydrologic modifications in the buffer, because everything else, there was just too much noise in the data to separate it out. So what we did instead is that we took that 200-meter buffer and that cursory walk through, and we shrunk it down to 100 meters. And then we set up, which my techs complained about quite a bit at first, a very rigid protocol about how this buffer is sampled. And essentially what they have to do now is that they walk 4 transects. At 3 points along each transect, they set up a 10 by 10 meter plot, and they look at what disturbances are present in that plot. You mark it as present. And they also recorded what is the impact, or how likely is that disturbance going to modify, degrade, or destroy the functions provided by the wetland they're sampling. At each plot, they also looked at what is the percent relative cover of native vegetation, and what Mary was talking about, percent soil disturbance, which generally equates to pugging by cows. How much of that 100-meter square plot is pugged, and how bad? So they did that for 12 plots in the buffer, and then between each transect, they were required to walk a meander through each quadrant, through each vegetation patch type present, and record different inputs and outlets of hydrology, anything that would fragment the buffer, or anything that would affect the hydro period of the site. And I don't know if there's more on that or not. The native vegetation and soils disturbance that we collected in the buffer, that information is then used by the buffer person to actually inform a couple indicators of ecological integrity that we collect in the rapid assessment. Hopefully reducing the variability between those two measures. For the floristic quality, remember the one thing I said, that the problems we identified from the Musselshell is that we only collected it at 36 sites, 25% of every place we sampled, and that it takes 6 hours on average to do one of these. Another one is that it takes a very experienced botanist to do. Honestly, I've done a lot of assessments, and I prefer to hire someone who is much better than me at it. So I could do it, but then I'm going to increase my variability in my data quite a bit. So these were the goals. This was the goal, and we said, okay, I want to revise our veg protocol methods so that we get comprehensive vegetation data at every single site we sample. And so we developed, we're calling it a rapid Fqa method. And this is a timed meander where our veg person does what is at a minimum a 20-minute meander through a plot identifying every vegetation species present. If during the last 5 minutes of that 20-meter initial 20-minute interval, they encounter 3 or more new species, you add 5 minutes on. So you can keep adding 5 minutes on to this base 20-minute timed meander until you're essentially not seeing 3 or more new species present. After they have gone through and they've completed their veg, the presence of all species in the plot, they then record the percent cover of each species, and then the cover class. So some other things that they're collecting at the same time. 5 minutes, okay. After they've collected the percent cover of each species, they use that data in the field to make several just easy calculations. Percent cover of native species, percent cover of noxious weeds, aggressive graminoids. We also have an indicator of ecological integrity, that is percent cover of plants that respond to increased nutrients and ones that respond to increased levels of salinity. So this person has covered this whole area, identified all plants, and is able to answer those questions as well. We just finished up the field season last year, so I haven't had the chance to really analyze all of the data yet to say, hey, it helped us with our disturbance gradient. But some of the things we noticed is that on average over the course of 2 field seasons, the rapid assessment has taken us about 2 hours and 45 minutes. And this is largely dependent on site complexity and also difficulty of the terrain. But across what is now 110 sites, 2 hours and 45 minutes is about average. For the person to walk the buffer, record all of their information, and fill out all the data sheets that they're required to is generally done within an hour to an hour and 15 minutes. The veg person, the average amount of time they spent walking and recording vegetation was 24 minutes per site. This went up depending on, obviously, site complexity. I think the maximum we had at any site was 45 minutes to identify all species. Just in my initial look and through the trainings that we have done, we have seen an increase in accuracy and precision and quite a decrease in the variability between observers calculating the same metrics. We also, when I first started to do this rapid FQA, I wasn't 100% sure, all right, how good is this going to be? Is it going to work, and is it going to give me the data that we need? It's been done. We didn't develop it ourselves. This is based off work out of Minnesota. So there was some research there to say, hey, this is good. But to test that, what we did in 2017 is that as we implemented the new rapid FQA methodology, we also continued to do intensive vegetation assessments at 25% of our sites. And then this past winter, or actually the first winter, we went and we said, okay, is there any significant difference in, we used only cover-weighted FQA metrics, but is there any significant difference in covered FQA metrics between our intensive data and our rapid data? And essentially what we found is that there is not. You'll see that the correlation here is actually really strong. And we did this across 6 different FQA metrics, and the worst correlation we had was like 87%. So we're pretty confident that as it stands right now, it's pretty good data. But as I said before, one of the problems is that it still takes a really experienced botanist who can do this quickly. And so the last thing that we really wanted to see is that to make this methodology usable and FQA metrics usable as disturbance or condition, we needed to simplify it. And we want to know, can we make a checklist of species, in particular common species, that someone could go out and do their timed meander, check just the common species that are already identified, record the percent covers, and will we get the same strength between the rapid FQA and the intensive? And to test this, what we did is we started and we created checklists. And we started with, our first checklist was 10% a species qualified for that checklist if it was present in 10% of our sites in the red rock. We then added 10% up, testing each time for significance between the checklist and the intensive, until finally we said, oh, our rapid FQA method is now statistically different on our FQA values from our intensive. And we hit that point when we used only 50% of the species was the species was present in only 50% of our sites. So we backed it up and said, you know, if we look at a checklist of species that are present in 40% of the sites we sampled in the red rock, maybe that would be a good checklist. That's future work to see, can we actually improve upon that and use even more common species. And then this is for questions. And if people have questions more about the Musselshell and what we did and what we found, actually in conclusion, there's a story map you can look at where we put the data out and our recommendations. How much did I go over?
Only a couple of minutes. I think you could take 2 questions,
okay,
and then we'll go to pick it up at the other end.
Okay. Any questions?
A couple of questions from Steve?
Todd?
Yes. Steve, did your disturbance include like physical disturbance when you said hydrologic hydrograph? Did you look at channel changes, physical manipulation of the ground?
It was physical manipulation, berms, dikes, dams, down cutting was picked up. I'm trying to think what else might be in there. Levees are a separate category. There are several. I think there's a checklist of 9 different hydrologic disturbances.